the zero product property. The objective of this lesson is going to be to find the values of x when the polynomial is equal to 0. That's what it means to find the zeros of a polynomial. And we're going to accomplish this goal today with the zero product property. So for these opening problems, we want to solve each of these equations. First one says 7 times x is equal to 0. I'll use my inverse operations. I'll divide both sides by 7, and x is equal to 0. Over here, we can use inverse operations again. Have 5 times x plus 3. We could distribute here, but I think that would just add an extra step. Instead, I'm going to divide both sides by 5 and see that x plus 3 is equal to 0. Then I can subtract 3, and we'll have x is equal to negative 3. So our zero product property says that if two or more quantities have a product of 0, then one or more of those quantities is 0. So a quantity is just going to be some value, some numerical value. The product means that they're being multiplied together. And one or more of those things that are being multiplied has to be 0. So if we look at our opening problems, we had two things being multiplied, 7 and x, and their product was 0. And look at that, one of those quantities was 0. We proved that x had to be equal to 0. Over here, we had the product of two quantities, 5 is one quantity, and the other being x plus 3. Well, 5 is definitely not equal to 0, the same way 7 was not equal to 0. But if you look at this quantity x plus 3, this does turn out to be 0. We found the value of x was negative 3. So if we were to plug this in, negative 3 plus 3, that's 0. So we showed that in order to have a product of 0, one of those values, one of those quantities has to be 0. Given that idea, we can expand that into multiple quantities being multiplied together with variables. So in number 1, we want to use this idea of a zero product property to find the values for x. Now, just like in that last lesson, we could have more than one answer for these types of problems. All of these problems, if you notice, are polynomials of a degree higher than 1 for the most part. Right? If you were to distribute, you would get an x squared term here. So let's check this out using the zero product property. This pretty much says that when solving, you can take each quantity and set it equal to 0 and solve. So either x is equal to 0 or x plus 2 is equal to 0. So this one's already solved, right? We have x all by itself and it's equal to 0. So this is one solution. This thing over here is going to provide another solution. I can solve for x by subtracting 2 from both sides, and x is equal to negative 2. We can express our answer in a solution set. X is equal to negative 2 or 0. So if I were to plug in either of these numbers into the equation would be true, right? Because if I put a negative 2 here, that would be 0, and 0 times anything is 0. And if I put a 0 in for x, 0 times anything would be 0. Let's do the same thing for number 2. We have 3 things being multiplied. I'm going to take each of these items, each of these quantities, and set them equal to 0. The first piece, negative 5 equal to 0, well, that doesn't make much sense at all. I'm going to put a slash through this equal sign, and I'm going to ignore that as a solution. The next one I can solve. I'll add 3 to both sides. X equals 3. Over here, I can subtract 4 to both sides, and x could be equal to negative 4. So I have 2 possible solutions, negative 4 or 3. Look at number 3. I have 2 quantities, 2x and x plus 5. So I'll say 2x could be equal to 0, or the x plus 5 is equal to 0. Over here, to solve for x, I'd have to divide, and x is equal to 0. Over here, to solve, I'd have to subtract, and x could be equal to negative 5. So again, 2 solutions, negative 5 and 0. At this point, pause the video and give 4 through 9 a try. Once you've given it a proper go, unpause the video, and watch my solutions. Okay, so let's see how you did. So looking at number 4, we have 3 quantities, 2, x plus 4, and x minus 4. So I'll set each one equal to 0. So 2 is definitely not equal to 0, so I'm going to put a slash through the equal sign and ignore that as a solution. For x plus 4, I can subtract 4 to both sides. For x minus 4, I can add 4 to both sides. So we have either negative 4 or positive 4. We can use our solution set, or we can use our plus minus symbol, because it's saying that x could either be positive 4 or negative 4. Number 5, we have 2 quantities, 3x plus 7 and 2x minus 4. These are both representing two-step equations. So first I'll subtract 7. Then I can divide by 3. And I'll just leave this as the fraction 7 over 3. Over here I have to first add the 4. Then I can divide by 2. I don't have room for the solution set, so I'll just circle these answers. In number 6, I have 9 minus x, that could be 0, or 9 plus x could be 0. First I could subtract 9 from both sides, but that would create an additional step of me dividing by negative. So I'm just going to add x to both sides, and we'll have 9 is equal to x. Over here I'll subtract the 9, and x is equal to negative 9. You can put them in a solution set or say that x is equal to positive or negative 9. Right, number 7, we have 3 quantities. X is equal to 0, x plus 2 is equal to 0, x minus 8 is equal to 0. All right, this one's already solved for us because x is all by itself. Here I can subtract 2. And here I can add 8. Have you picked up on the pattern that the solution is always the opposite sign of the factor? Okay, 3 quantities here, x plus 3. We'll set that one equal to 0. X minus 3, and x minus 1. If I use my pattern and say that the result is always the opposite sign of the factor, I would have x equals negative 3, x equals positive 3, and x equals 1. I can put this in a solution set as x is equal to 1 or plus minus 3. Finally, in number 9, we have 4 quantities. 1, 2, 3, 4. So I'm going to set each one equal to 0. X equals 0. 2x plus 5 equals 0. 7 minus x equals 0. And x plus 3 equals 0. So much stuff. This one's already solved for us, so we don't have to do anything there. Here we can subtract 5 first, and then divide by 2. And I'll leave that as negative 5 over 2. Here I can add x to both sides, and we'll have x is equal to 7. Over here I can subtract 3 from both sides, and x is equal to negative 3. So my solution will be x is equal to negative 5 over 2, negative 3. Oh man, I tried to put these in numeric order. You don't have to, it's okay. I just like to, but I did it wrong. This one should come first if I want it to be a ascending order. X is equal to 0, and x is equal to 7. There we go.